Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electromagnetism from March 2021, Paper 4, Variant 2. In this question, we will discuss how to use right-hand grip rule and Fleming left-hand rule. We will also discuss about forces between two wires if current flow in same direction in two wires. So we will compare the magnitude of the force between two wires and also direction of forces between two wires. These points are very important to understand motor effect and also to understand electromagnetism. For question number 8, it is given to us two long straight wires P and Q are parallel to each other as shown in figure 8.1, and direction of current in each wire is also given. So this is direction of current. The pattern of the magnetic field lines in plane normal to wire P due to current in the wire is also shown. For part A1, we need to draw arrows on the magnetic field lines in figure 8.1 around wire P to show direction of the field. So in this case, we have direction of current. We need to find direction of magnetic field. So we have to use right hand grip rule. So let's try to understand a little bit about right hand grip rule. When we can use this one, right hand grip rule means you have to use your right hand, and right hand can be used to find direction of magnetic field. It can be used to find direction of magnetic field, or it can be used to find direction of conventional current. So if one is given, we can find the other one. If we have direction of conventional current, we can find direction of magnetic field. If we have direction of magnetic field, we can find direction of current. So vice versa is true. Mean if this is given, for example, if this is given to us, we have direction of magnetic field, we can find direction of current. And vice versa is also true. We can go this way or we can come this way. So this is true. Now in this case, we have current. Current is given, we need to find direction of magnetic field. So simply you have to use your hand like this. So thumb is in direction of current flow. So these fingers, they are telling us direction of magnetic field. So in this case, direction of magnetic field is counterclockwise. Means this is direction of magnetic field. So this is direction of magnetic field. Counterclockwise, CCW. That's all what you need to do for this question. Let's try to understand one more point. If we look at magnetic field at this point, so magnetic field here is into the page. So magnetic field here is into the page. So anywhere here, magnetic field is also into the page. Because magnetic field here is into the page. So anywhere here, magnetic field will be into the page. And into the page, we use symbol X for that. So magnetic field here is into the page. Magnetic field here is also into the page. So we will write down here, magnetic field here is into the page, because we need this point to answer next question. For this question, simply you need to draw these arrows. For the second part, we need to determine direction of the force on wire Q due to the magnetic field from wire P. So this is our wire Q. So if we need to find force on this one, means force on Q, this will be equal to BIL. So this is BIL. But this B has to be external magnetic field. I is current in wire Q. We can say this is Q. This is L is length of Q. So we can say this magnetic field is due to P, and this is current of Q, and this is L of Q. B due to P. We have already discussed the magnetic field due to P at this point is into the page. So magnetic field here is into the page. So here magnetic field is also into the page due to wire P. Now in this wire, current is flowing up, we need to find out direction of force. So we have to use Fleming left-hand rule. To find direction of force, we have to use Fleming left-hand rule. So we will say FLHR, Fleming left-hand rule we have to use. So Fleming left-hand rule is used for current, is used for magnetic field, and is used for force. If two of them are given, third one we can find. So first of all, force. We use thumb for force, and we use index finger, means this finger, index. So let me write down index. For B, we use index finger for direction of B, and middle finger we use for current. So here we have middle finger. Middle finger is used for current. So we can say this will tell us direction of force, and this will tell us direction of magnetic field, and this one will tell us direction of current if other two are given. Now simply we have to use, so in this case, for example, direction of current is up. So direction of current is up. So this is direction of current. As you can see here, direction of current is up. And magnetic field is into the page. So magnetic field is into the page. So as you can see, this finger is pointing into the plane of the page. So this is direction of force. So the force is to the left. So simply we have to write down here, force on Q is to the left. So force on Q is to the left. So this is what we have to write down for second part. But another way to understand this one is, if current flow into wires in the same direction, we have discussed this point in previous videos. If current flow into wires in the same direction, these two wires, they will attract each other. But if current flow into wires in opposite directions, these two wires, they will repel each other. Means the force on this wire will be this way, and force on this wire will be this way. So these two, they will repel. But if current flow into wires in the same direction, these two wires, they will attract. So without using Fleming left-hand rule, you can find out direction of force on wire. So in this case, direction of force is to the left. Let's move on to next part. For the next part, the current in wire Q is less than current in wire P. So it simply means that IQ is less than IP. This is given to us now. We need to state and explain whether the magnitude of the force on wire P is less than, equal to, or greater than the magnitude of the force on wire Q. So first of all, let's try to understand how we can find magnitude of force on any wire. We have already discussed a little bit about force on Q. So if we talk about force on Q, we can write down here, this force is equal to BPIQ/LQ. But B is equal to, let me write down here, this is very important point. Magnetic field around any wire is equal to mu naught I divided by 2 pi r. For example, if we have here, this is wire, let's say current in this wire is I, and we want to find out magnetic field at this point, so we can use mu naught I over 2 pi r. R is the distance between wire and that point, so this one is over r. So BP we can replace with mu naught, this is current in wire P divided by 2 pi r, and this is multiplied with IQ times LQ. So this is how we can find out magnitude of force on wire Q. But if we need to find out magnitude of force on P, we have to use magnetic field due to Q, current in P, and L of P. Now, if we write down magnetic field due to Q, we will write down mu naught IQ divided by 2 pi r. And this is multiplied with IP times LP. If LP, for example, so let me write down this point, is very important. If LP is equal to LQ, if LP, this is equal to LQ. So these two equations, they are the same. Or we can simply say that, in this case, we can simply say that force over length, means F over L. This is equal to mu naught I1, I will simply say I1, I2 divided by 2 pi R. So we can say in this case force is directly proportional to product of current. So it doesn't matter if any current is higher or lower, force on two wires will be the same because current is proportional to product of currents in two wires. So this is the main point we need to understand. So in this case magnitude of force on two wires will be the same but opposite in direction. So let me show you how you can write down answer. This is how you can write down your answer. This answer you can explain using two different methods. So this is our statement. First of all, this is our statement. In our statement, we have said magnitude of forces on two wires are equal. You will get 1 mark for this one. And second one, this is your explanation. You have explained. So this one is over explanation. So this is explanation. We have said force is directly proportional to product of currents in two wires. So you will get the second one. And other way to explain this one, you can say that according to Newton's third law, forces have same magnitudes and opposite directions. So let me clean this one. Maybe you will not be able to see this part. So let me make some space for you. So second point, second way to explain this one, you can say forces are equal in magnitude according to Newton's third law and they are in opposite direction. So this is, you can also say for explanation of this question. This question is very common in past papers. So you need to be very clear about this. Part B is about MRI, and MRI is not part of syllabus for 2022. It's not part of syllabus for 2022. This is from old syllabus. So we will not discuss this question, but I will only write down the answers for this question. If you're curious, you can go through this answer. So this is the answer for part B. But this question is not part of syllabus for 2022 and onwards. And this question is from old syllabus. So we will not discuss, but you can see the answers for this question here.